So this is my short video on graphing tangent functions. Hopefully you recall that tangent is equal to sine over cosine. So over here I have a partial unit circle, and I want to look at the 5 critical values that we always know we start with at 0 degrees, 90, 180, 270, and 360 degrees. Or in radians, 0, pi over 2, pi, 3 pi over 2, 2 pi. So at 0, if I take sine over cosine, 0 divided by 1 is 0. So I'm going to kind of make a table here, and a little xy table. So at 0, tangent is 0. Let's move to pi over 2. And I'm skipping a space for a reason. At pi over 2, 1 divided by 0. And so you'd have to remember that sine are the y values, cosine are the x values on the unit circle. 1 divided by 0 is undefined. Let's keep going. 0 divided by -1. So at pi, I have 0 again. And then down here, -1 over 0. At 3 pi over 2, I have undefined again. And then I get all the way back to the top at 2 pi. It's 0 again. So we got this 0, undefined, 0 pattern. But if you remember, if I'm doing sine over cosine, there are a couple other values on my unit circle that could be beneficial. Anywhere that the values are the same. So for example, at 45 degrees, which is pi over 4, we have square root of 2 over 2, comma square root of 2 over 2. Well, if I do, any time that I put something over itself and they're identical, it gives me 1. So the cool thing is I can go back and add these values. Square root of 2 over square root of 2 is 1. Over here there's another one, but it's negative square root of 2 over 2, comma square root of 2 over 2. So that's going to give me -1. And that is at 3 pi over 4 radians. Down here at 5 pi over 4 radians, they're both negative, and so because they're both negative, negative divided by a negative will give me a positive 1. And then over here at 7 pi's over 4, the cosine value is positive, but the sine value is negative, meaning I'll get -1. So now I have this really nice periodic function, 0, 1, undefined, -1, 0, 1, undefined, -1, 0. So let's plot that out. Zero, pi over 4, pi over 2, 3 pi over 4, pi. Let me space that out a little bit more. Pi, and directly in the middle 3 pi over 2. So now we'll plot my points at 1 and -1. So I've got the point 0, 0. I've got the point pi over 2 undefined. I've got the point pi 0. I've got the point 3 pi over 2 undefined. And I've got the point 2 pi 0. Go back and add those blue points. We got pi over 4, 1. We got 3 pi over 4, -1. 5 pi over 4, 1. We have 7 pi over 4, -1. And that's all we're going to do. So now I'll actually draw my graph. We'll do it in green. All right. And so we're going to analyze this graph. The first thing we need to remember are that when we have an undefined x value, we call those asymptotes. You have to remember that from a previous chapter. So anywhere we're undefined, we have asymptote. So our line will go up infinity and get so close to that value, but it'll never actually hit that value because it can't exist. And so how do I relate this to sine and cosine? Well, if you remember our sine graphs and cosine graphs, it took one whole revolution of a circle, of our unit circle, from 0 all the way around to 2 pi to complete one cycle. But if you look, here's half of a sine cycle, there's the other half, so that's one cycle at pi. If I look, there are 2 full cycles, 1 cycle and 2 half cycles to make 2 full cycles between 0 and pi. So what does that tell me? It tells me the period of a tangent function is pi instead of 2 pi. And that's going to prove to be critical. So let's kind of go into some generalities here. Y equals tangent of x, the parent function. So just like sine and cosine, it's going to have an a value out here in front and a b value out in front of your x. What they mean is slightly different. The a value for tangents, I call it my not amplitude. The b value is the number of cycles, not between 0 and 2 pi, but between 0 and pi, because tangent repeats at pi instead of 2 pi. And so now we have to find the period. Period, instead of 2 pi over b, which is what it is for sine and cosine, it's just going to be pi over b. And our reasoning is because the typical period of a tangent function repeats every pi, and so if we take our typical period divided by our number of cycles, that'll tell you what our period of whatever graph we're given. The other thing that I'm going to show you is how to find the asymptotes. You can find the asymptotes by doing plus or minus pi over 2b. So let's go back to the previous page and apply this to all of that. So I'm going to erase my table because we've already used it to graph. And so I can do some calculations here. So I showed you that this is the graph of y equals tangent of x. So my a value in this case is 1. And here's why it's called the not amplitude. It's still going to tell me what these values should be, but it doesn't really express an amplitude. It expresses where the points fall on our tangent line. So if you held it sideways, it would sort of look like an amplitude. The distance between this point here and that point there is 1. But for labeling purposes, you just need to know that that's what you're labeling your y-axis as. My b value in this example is also 1. A value, b value. And so to find my period, I do period equals pi over 1, which is just pi. And that makes sense, right? Between 0 and pi, my function should repeat half and half. So I complete one cycle between pi. So that's what we want. That's good. And so now I need to find my asymptotes. My asymptotes are at plus or minus pi over 2b, which is pi over 2. And so my asymptote, if you look, is at pi over 2. If I looked at the negative side over here, there would also be an asymptote at negative pi over 2. And so now, how do I find all these little individual check marks in between? Well, just like what we did with sine and cosine, if you take your period divided by 4, it'll tell you your scale. So my period is pi. Pi divided by 4 is pi over 4. That means each of these marks is going to be pi over 4. So I've got pi over 4. 2 pi over 4 simplifies to pi over 2. 3 pi over 4. 4 pi over 4 simplifies to pi. 6 pi over 4 simplifies, 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2. Then I have 7 pi over 4. And then I have 8 pi's over 4, which simplifies to 2 pi. So this tells me my scale, this tells me my asymptotes, this tells me my period, this tells me my not amplitude, my value of my y's. And so now I can sketch any tangent function. So let's give it a try. Y equals tangent of 2x, or 2 theta. So let's go ahead and label everything. A is 1, B is 2, period is pi over b, which is pi over 2. My asymptotes are plus or minus pi over 2b. So my asymptotes are going to be at plus or minus pi over 4. And then lastly, if I take my period and divide it by 4, or times it by 1/4, each of my marks is going to be worth pi over 8. So with that information, with my pi over 8, with where my asymptotes are, I can sketch my graph. So remember, we flip it if it's negative out in front, we sketch it and label it. With tangent, I tend to flip these two around, but you don't have to. You can sketch the generality. So I've got my tangent graph here, and I know that there's going to be an asymptote, so I'm just going to kind of evenly space these here. I don't know how many I'll need, so I'll just keep going. So there's going to be an asymptote. Every 4 marks, there's going to be an asymptote. 1, 2, 3, 4. So there'll be an asymptote here. Oh, I ran out of space. There'll be an asymptote somewhere over there. So now I need to sketch my graph. I know it's going to be here, then at 0, then here, and look like that. It's going to be here, then at 0, then here. Sketch my graph. It's going to be here, then at 0, then here. Sketch my graph. Now I just need to go back and label it. So I've already found out that my asymptotes are plus or minus pi over 4. So I know that that's negative pi over 4, and I know that this is pi over 4. Now I know that my scale is pi over 8. So I'm going to start at 0 and add pi over 8 every time. So pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, 6 pi over 8, which is 3 pi over 2. No, that's not right. 1 pi over 2, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8 is 2 pi over, is 3 pi over 4. And then I have 7 pi over 8. And 8 pi over 8, which is just pi. I'm going to go ahead and stop there. I mean, I could keep going, 9 pi over 8, so on and so forth. But I'm going to go ahead and just stop at pi. And so my b value tells me that I should have 2 cycles between 0 and pi. So let's look at that. If I start at 0, I have half, then I have 1 full cycle, and then I have another half. 1 plus 1/2 plus 1/2 equals 2. So I know I graphed it correctly. And so, I could keep going all the way to 2 pi, or I could keep going in the negative direction, but I just wanted you to see. So that is a perfectly acceptable graph. I would probably want to add negative pi over 8 in that direction. All right, one more example, and that keeps us right around 15 minutes, so that's pretty good. Let's do y equals, I'm just going to, for the heck of it, make it 2 tangent of 3/2 x. So a value is 2, b value is 3/2, period is pi over 3/2. So that's essentially saying pi divided by 3/2, meaning I flipped that fraction. Pi over 1 times 2/3, so my period is 2 pi over 3. Now I need to find my asymptotes, which are plus or minus pi over 2b. Well, 2 times 3/2, my 2's cancel out, leaving me with plus or minus pi over 3. Those are my asymptotes. Now I need to find my scale. 2 pi over 3 times 1/4 gives me 2 pi over 12. which is pi over 6. So now I've found my scale. So let's graph. And again, I'm going to kind of just scale this out here with some tick marks. Don't really care what they are. The only thing I'm going to do is I'm going to label this as 2 and negative 2 now, instead of 1, because my a value is 2. So again, just labeling it. So I know I have asymptotes here, and I know that that's plus or minus pi over 3. So negative pi over 3 and pi over 3. And so basically every 4 tick marks, 1, 2, 3, 4, there will be an asymptote. 1, 2, 3, 4, there will be an asymptote. 1, 2, 3, 4, there will be an asymptote. Awesome. And so now I know my scale is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6 simplifies to pi over 2. 4 pi over 6 simplifies to 2 pi over 3. 4 pi over 6 simplifies to pi. 5 pi over 6. 6. Oops. I missed one here. Hold on a second. 5 pi over 6 goes here. Then 6 pi over 6, which is pi. Then 7 pi over 6. Then 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. And then 10 pi over 6, which is 5 pi over 3, and then 11 pi over 6, and then 2 pi. And I'm just going to keep going. 13 pi over 6, and then 14 pi over 6, which is 7 pi over 3. Just because I already made all those tick marks. And so now I just plot my points. Let's use purple. So I have an asymptote. So at this value, at negative pi over 6, I should have a dot right there at negative 2. Then at 0. Then at 2. Negative 2. 0. 2. Negative 2. 0. 2. Negative 2. 0. 2. And so I'll sketch my tangent graph. And so I need to see that I have 1.5 tangent functions between 0 and pi. So if I start at 0 and I go to pi, I have a half and then a full. So I have 1.5 cycles. That's all for my video. Thank you. Bye.